Hello everyone. So this is another video. I'm gonna prove actually law of cosine in this video. Okay. So let's get started with a triangle because I'm gonna use this triangle to prove it. So again, I'll just start with labeling. So let's say this is ABC. And so since this is vertex B, I'm gonna call this is B. This is vertex C. I'm gonna call side AB as C, and this is gonna be A. So the law of cosine is actually a relation between three sides of a triangle and one of the angles in that triangle, okay? So let's take this angle or this angle. It doesn't really matter actually. Let me take this angle. I'm gonna call this guy as angle beta, okay? So I'm gonna find a relation between side ABC and this angle beta. I mean, I can take A or C, whatever, it doesn't really matter. So, but to do so, we really need to have a right triangle so we can actually use our trig ratios, right? So let's try dropping the altitude from one vertex to the other side, this is kind of common one that we can use it. So I will just drop this guy and then let's call this is H. And I'm gonna call this point is like H as well, but this is distance H. This is, I guess, intersection of these two sides. Okay. So if I want to take the sine beta, okay, if I take this sine beta, the sine was opposite over hypotenuse, right? The opposite for this angle is H, so that will be H over hypotenuse is C. And if I want to find the H itself, so I can multiply both sides by C. So the H will be C times sine beta, okay? Keep this in mind. Okay, so I'm gonna leave it for now. Okay, and the second one, I'm gonna use the cosine beta now. So if I take the cosine, that is just adjacent over hypotenuse, which would be H over C. And if I want to find the BH itself, because that's something that I don't know, I can multiply both sides by C. So that will be C times cosine B equals BH. So let's keep this in mind as well. And what I'm going to do next is, I have a right triangle. I know one side H, which is, I know that side in terms of side C and sine beta. And our goal is finding a relation between three sides and one of those angles, not this H. So which means I don't really need this H. So I need to replace H with this equal value. And the same idea, I'm going to use a Pythagorean in this case, but I don't know the HC, right? So HC, I can write as BC minus BH. So BC is just A, and then BH was right here. So C times cosine beta. Okay, so that is my HC. And let's keep this in mind as well. So as a next step, like my next step, I will try taking this triangle and using Pythagorean. So the Pythagorean, I'm going to square this leg, I'm going to square this leg, I'm going to square this hypotenuse. So the AH squared plus HC squared is equal to AC squared by Pythagorean. So AH was the height of the triangle, which is this guy, C times sine of beta, and that needs to be squared, plus HC is basically this difference, which doesn't look like fine, but C times cosine beta, and then I need to square this guy, equals AC squared, which is B squared. So let's clean this mess a bit, but I'm gonna square these both. So this is a product of two things. Now, this is a number, this is another number, you multiply to get the second power. So basically that's C squared times sine square beta, and that's plus, and this is a number, and then the product is also another number, but a number minus another number is just the binomial of the second power. So this is basically square of binomial. So if you don't know about that. So probably you can write a minus c times cosine b and write it again, just multiply those. But if you expand this binomial, so you will get a square and minus 2 times this number times this guy, which is going to be a times c times cosine b, beta, plus the square of this guy, which will be c squared times cosine square beta, which is equal to b squared. Okay, so I was expecting something better, but now this is a big mess, as you see. So what I see right now, I have c squared times sine square beta. There's a cosine square beta with the c squared. So if I combine these two guys together, okay, and I will just write those together. Okay, so that will be a squared minus, maybe I should leave a space for that. So minus 2 times a times c times cosine beta. And just a key reminder, so whenever you have, let me write here, so c squared times sine squared beta, and then this guy plus this guy, since c squared is common, so I'm going to pull that as a factor, so I can write this as plus cosine squared beta. So I hope that makes sense. I just pulled this guy and put it together. Since c squared was common, I just factor that c squared. And this is something we probably know. This is called the Pythagorean identity. Whenever you have square of a sine angle of a sine, and the square of the same angle, so that sum is equal to 1. And if you don't know about this one, so it's good to review the unit circle like relation. Maybe you can find that out, or you can just use the right triangle to prove it as well. But that is something called Pythagorean identity. So which is why this guy plus this guy is going to be equal to c squared times 1, which is just c squared. So right now, I'm going to replace this whole thing plus this whole thing is equal to c squared. So I'm going to write it right here. So that will be c squared. And that is equal to b squared. And this is actually our final step. So it looks like too long, and it's kind of harder to kind of remember. But it's basically you square one side, which is, let's say, this a, and another side, which is this one, and then minus 2 times of those two sides, which is a and c, times cosine beta. Beta is the angle in between those two sides, is equal to square of the third side. That is actually opposite to the given angle. And this is called law of cosine. I hope that looks not too bad, but that is how we can prove this law of cosine. Okay, so we will do some concrete examples. I hope that will make more sense, but this is how we can at least prove the law of cosine with the Pythagorean identity itself. Okay, so that is the video. I hope that makes sense.